Hi everyone. Welcome to H&M Technologies online training. So this is the video 43 generators and eld. Imagine you are processing a 10 million movie records or 10 million student records. If you load all of them into a list at once, your RAM explodes and the program crashes because the huge data list can't handle. So here the generators came to solve this problem. They gave you a data one item at a time. Only when you ask, no memory overload. It don't say them all the data into at once. It gives whenever you want that time only. So it's like using a necessary. Okay, let's build this step by step. Let me open our VS Code. Let's see first the problem with the lists. We have a basically lists are consume more memory. See that. So just I'm importing a sys system because I need to get a size of the list. So firstly a big list that is a value for a value in a range of 1 million and similarly, I am also creating a big generator that is same as this value for a value in a range of 1 million, right? Let's try to print the sizes of both list and generators. To get a list size, I am giving a 6 and get size of firstly our big list. Then I'm also printing generators data same as this sys dot get size of big generate. See the output here in bottom here. List size is 8448728 bytes, but you can see the generator size is 192. How low it is the generator size? So almost list size is 8 MB. You can see the difference in numbers here. Same thing, same data, a value in a range of 10 million, here also 10 million, same thing, but the sizes is different. The thing is, generator doesn't store anything. It produces a value on demand. When you ask, it produces. That's actually called as a lazy evolution. Now we know, so generators are basically less memory storing comparatively least. Okay. Now let's see what is the L keyword. L keyword basically it gives you a single item in a R function. Let's see how it is worked. For this, I am defining a function called get movies list. Inside that, I am not giving any parameters. So I'm just returning when I call that function. I just want data is a list of movies, Genedy and Animal KGF. These three movies I want when I call the function get movies list. Okay, this is a regular function. It returns the all at once, right? Now let's see a generator function. I define a function with here I'm telling a eld movie name or Genedy. So just I print a statement called elding or Genedy elding animal and elding KGF, and the downside I just eld Arjunity animal and KGF. So let's call this here nothing will print. Okay, see, nothing will print when I call with the print, then a printing with the next gen. See the output here, elding Arjunity output and Arjunity. So if I try to print again the same thing, the next movie elding animal and animal movie, and when I call the same again with the next and gen KGF, and again I tried, it says stop iteration. So there is no iterations after this. So this is the last one, 3 up to KGF. So what happens here, see, when I print next gen, here it happens like runs until first L and then it pauses. And then again, when I call this next gen again, it resumes until the next L. And same thing happened. It resumes until third L. It resumes until fourth L and up to fifth L. How many we create? How many we will create? Up to them, L will happen. Okay. This way you can get a single data or a item from a function with the help of this eld keyword. What exactly this eld doing is eld pauses the function and remembers exactly where it stopped and resume it as it is. That way the eld works. Let's see generators with loops, how the generators perform inside a loop. For this, I'm defining a function called Tollywood hits, and then inside I'm giving a start, comma, end. These are the parameters I'm giving. And another thing is current is start. Okay. Now while loop, while current is less than equal to the end one, so I'm building the formatter output like a movie is the current movie. So current one. Okay. Now current is I want always increasing. So current plus equal to 1, right? And I'm for looping this for movie, the value in a Tollywood hits, start and end index, I'm giving 1 comma 5 and then print movie. Okay, let's see. The L prints up to 5, 1, 2, 3, 4, 5. Movie 1, movie 2, movie 2, movie 4, movie 5. So all at a time, the printed. Or you can just take a first 3 if you want. I'm using a gen as a Tollywood hits of 1 comma. This time I'm breaking 100. Okay, here I'm printing as usual how we use before one. Next gen, the first one will print, and the same thing when I try to print a second movie, the next and gen. This time the second one will print. This time the third one. So you here one thing you need to observe. We have a movies list. Tollywood hits up to 100, but here I got only 3. So with the help of these generators and the L keyword, we can get a data how much we want based on the situation and condition. So the still we have a remaining 92 or never computed. They never ran. They just saying staying. So this is the advantage of this generator and mostly the L keyword. Okay. Generator expressions. They're just like comprehensions, list comprehensions have square brackets. So generators have braces, just braces. Okay, let's see how it works. Just import a sys system and then a list comprehensions are just like a LC. Then our list comprehension is x square root of 2 and for the value in a range of 1 million. I'm printing the size of that list comprehension and just saying sys dot get size of LC. So the same way I also create a generator expression. So generator expression is same as the previous one, but I'm denoting using a braces and x square root 2 for the value in a range of same 1 million. And then also I'm printing a size of this one sys dot get size of generator expression. So see the output here 8448728 almost 8 MB and 200 is our generator expressions memory. Let's see how this generator expressions work inside sum and max, min, so basic methods. For this, I'm taking a ratings, a list of ratings 9.0, 8.6, sorry, 8.6, and 7.8, 9.6, and 7.1. Some list 5.7, 6.3. Okay, fine. We have a list of ratings. Now I want a total. So total, I'm using a sum of a value for value in ratings. Okay, I'm giving a filter here to ratings, and if a value r is greater than equal to 8.0. Okay. Now I want to count how many is there, how many ratings is there. So I'm counting sum of value 1 for or in a ratings same filter if value is greater than equal to 8.0. Okay, then printing. I am printing the formatted output, which is sum of top ratings. This is a total, and also I'm printing number of top ratings. That is a count. Okay, you can see the output here. Sum of the top ratings 27.2. So the ratings which are more than or equal to 8.5, those sum is 27, and the number of top ratings we have three. One is above 8.0, 8.6 above, 8.6, 9.6, and 9 point. So we have three ratings above 8.0, and the total is 27.2. Yeah, works fine. Great. We can use this generator expressions inside this sum and all. Let's see some real world stuff. So reading large files from our data local or cloud systems. Okay, with the help of file handling topics we are going to use here. So just recall the topics that we discussed in this file handlings. Okay, to open the files we use with open, and which mode we are using, w read. Okay, and closing the files. So all are we going to use now. So with the help for open, and the file name is all movies dot txt. Okay, so in the mode of w mode, so w mode will do one thing. So if it is already existed a file, then it removes the create a new one. If it is not, then it creates a new one. So I'm just taking as a file f, and then for looping for value in a range of 1 comma 10,001. So in a file f, I'm writing movie is I, the value I, and rating is I, and 10 modulus division 10, and the plus 1. There's a math thing. So creating a test file with 10,000 lines is done, and now it's time to read one line at a time. So we're going to never run a full file all at a time. And for the defining read movies, the file name is my parameter. Here inside with open file name in the mode of a read mode, this as a file. Then for line in a file, I'm yielding to get a one line yield line dot strip. Why you using strip? Because without getting a raw data, we just use a strip, all stripping the slash and things in our data. Okay, now that's done. Now it's time 10 lines with almost zero memory, so we're going to process them. For a line in a read movies, file name is all movies dot txt. If in a line 9.0 in a line, or I'm just increasing this one with the one, and now I'm printing the count of high rated movies. See, the output is high rated movies 2000. Those are high rated movies in since 9.0 or 10.0. From our 10,000 list, we'll get 2000 of high rated movies. So whether the file is 1 GB or 1 MB, that doesn't matter. Memory uses stays flat. Whenever we need, that time only it compiles, it runs the file. Otherwise, it stays calm. This is a real powerful uses in a real-time codes like this, and the generators pause comes how we are using them. It's always based on how we are using the generators. Now let's see the generators versus the list, a small comparison. So then you'll know where to use this list and when to use the generators. So complete picture you will get it. Use a list when you need to access an item by index. Okay, so when you're going to use the index numbers, that time use a list. And so when you're going to iterate a multiple items, that time also use the list. And the data is small, and you don't need to use the generators actually, so that time we'll go with the list. So, and one more thing is when you need a list inbuilt methods like length, results, and sort, and some other list inbuilt methods. That time we must need to go with a list. And use the generators when a data is a large millions of records. That time we must need to use generators, and you only need to iterate once, and building a data in a pipeline or reading from a file or a stream. So in that time we use generators mostly, so that lazy evaluation like yielding. So we need a one or two items specifically from the millions of records. At that time we use lazy functions. See here we have practice questions as usual, beginner and advanced level. Pause the video and go through each question we have, and in a best on level, open your VS Code and try all of this. See, in this video we done generators are memory efficient, and what is a lazy evaluation. So using L to pause resume function, and generator expressions. So generator expressions using the browsers, and which is the best for large file and one-time iterations. Where so difference between the list and generators. We saw everything in this video about generators. Next, we are going to cover about decorators. Okay, see you there and practice all the questions we have. And thank you for choosing H&M Technologies online training. Bye bye. Happy coding.